Okay, for this review problem, we'll take a look at the interval of a convergence for summation n equals 0 to infinity, n times x to the n over 3n plus 1. So once again, we apply the ratio test to determine where this power series converges. So limit as n goes to infinity, absolute value. The denominator will be the nth term, n times x to the n over 3n plus 1. And the numerator, I'll have the same thing, except everywhere I see an n, I replace by n plus 1. Written another way. So we have n plus 1. Let's see, here we have over n. We also will have the denominator here, so that comes up top, 3n plus 1. This denominator stays low, 3n plus 4. And lastly, x to the n plus 1 over x to the n is just simply x. And I want this to be less than 1. All right, now we can use L'Hopital's rule here, but we see that if I were to multiply this out, the leading term would be 3n squared. Likewise here, the leading term would be 3n squared. So it's quadratic top and bottom. And so I can divide the leading coefficients to get the limit. I get 3 over 3 times the absolute value of x. And that, of course, is just simply going to be the absolute value of x. Now, we want this to be less than 1 in order for it to converge. So the series converges absolutely. For absolute value of x less than 1, or written another way, for x between -1 and +1. So that is the interval of convergence for this problem. The radius convergence would be the one I see here.